Hello students, today we'll discuss a numerical problem. This is the first problem based on distance and displacement. Student, this is a problem from our NCERT textbook. Question number 2, page number 100. Let's read the problem first. A farmer moves along the boundary of a square field of side 10 meter in 40 seconds. What will be the magnitude of a displacement of the farmer at the end of a 2 minute 20 seconds from his initial position? Students, in this question, they're asking us to calculate the displacement. A farmer moves along the boundary of square field. Let's draw the situation, students, here. This farmer moves along the boundary of a square field. Say, suppose we have this square field. The side of this square field is 10 meter. This is 10 meter. Side of the square field is 10 meter. A farmer moves along the boundary of a square field of side 10 meter in 40 seconds. So let's say, suppose the farmer starts movement. Farmer starts his motion along the boundary of this square field of side 10 meter, and it takes 40 seconds to make one round of this square field. What will be the magnitude of displacement of the farmer at the end of a 2 minute 20 seconds? At the end of 2 minute 20 seconds from his initial position. So he started from his initial position. At the end of a 2 minute 20 seconds, okay students, we have to calculate the displacement of the farmer at the end of a 2 minute 20 seconds. Student, this farmer makes one round of this square field in 40 seconds. That means he covers a distance of 40 meter in 40 seconds. So here is the problem. Side of a square is for 10 meter. Distance covered by the farmer in 40 seconds is 40 meter. So 10 plus 10 plus 10 plus 10, 40 meter. He makes one round and covers a distance of 40 meter, and it takes him 40 seconds to make to cover a distance of 40 meter. Now what is his speed? We know his distance. He covers a distance of 40 meter. It takes 40 seconds time. So speed of a farmer is distance divided by time. That's 40 meter by 40 second equals 1 meter per second. So his speed is 1 meter per second. It takes him 2 minute 20 seconds. He moves around this square field for 2 minute 20 seconds. So total time taken by the farmer is 2 minute 20 seconds. Now 2 minute 20 second means how many seconds? So 2 into 60, 1 minute equals 60 seconds. So that's why 2 into 60 plus this 20. So total of 140 seconds. So he moves around this square field for 2 minute 20 second means 140 seconds. So total distance covered by the farmer in this 140 second duration is distance. We know the distance formula, that's a speed into time. So speed is 1 meter per second and the time taken is 140 seconds. So the distance covered by this farmer at the end of a 2 minute 20 second is 140 meter. So this is the distance covered by the farmer at the end of a 2 minute 20 seconds. Now students, let's understand. He covers a distance of 140 meter. When he covers a distance of 40 meter, how many times he revolves, or we can say how many times he completes the revolution of this square field. So number of revolution made is 140 divided by 40. Now students, he covers a distance of 140 meter. So 140 meter means, let's find out. If he makes one round of this square field, distance covered is 80, not 80, 40. One round 40, another round, another 40, so total of 80. One more round plus 40, so 80 plus 40 makes 120 students. Means when he covers a distance of 120 meter, he makes 3 complete round of this square field. But he covered a distance of 140 meter. Now still 20 meter more remaining. So 120 meter, 3 revolutions. So 120 plus 10, 130 plus 10, 140. That means he makes 3.5 revolutions. At the end of a 2 minute 20 second, he makes revolution. He makes 3.5 revolutions. So let's find out where he stops at the end of 2 minute 20 seconds. So first revolution, second revolution, third revolution, and third revolution means 120 meter. Now 120 plus 10, 130, and this is 140. That means at the end of a 2 minute 20 seconds, he makes a revolution of a 3.5 and he stops at this point. Now student, his initial position is A and his final position is C. Now you know student what is displacement means. Displacement is the shortest distance joining the initial and the final position. So we have a shortest distance, this line segment, straight line segment joining initial position A and C. So we have to calculate the length of this AC. Now in this right angle triangle, we can use the Pythagoras theorem to calculate this shortest distance. So 10 square plus 10 square equals 100 plus 100. So it's a 2 into 100, 10 root 2 meter. Now 10 into root 2 is 1.414. If you multiply this, you will get the value 14.4 meter. Now students, so this is the displacement. This is his displacement at the end of a 2 minute 20 seconds. Now students, we have another problem from our NCERT textbook. This is question number 2 from page number 103. A bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. Find the acceleration of the bus. Student, a bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. So student, initially the bus was moving with this speed of 80 km per hour. That means the initial velocity is 80 km per hour. And you know the symbol to denote the initial velocity? It's a U. Small u equals 80 km per hour. U means initial speed. So initial velocity 80 km per hour. And the bus decreases the speed from 80 km per hour to 60 km per hour. So final velocity, it's a 60 km per hour. Final speed is a 60 km per hour at the end of a 5 seconds. At the end of 5 seconds, the bus speed has decreased to 60 km per hour. Now students, this speed unit is not in SI units, so we have to convert this into SI units. So kilometer per hour should be converted into meter per second. So 80 kilometer, 80 into 1000 divided by 3600 seconds. Kilometers should be converted into meter, so that's why multiplied by 1000. Students, 1 kilometer equals 1000 meter. So that's why 80 into 1000. Now 1 hour equals 3600 seconds. So to convert 1 hour into seconds, we have divided by 3600 seconds. So if you simplify this, you'll get the value 200 by 9 meter per second. Similarly, 60 km per hour should be converted into meter per second. Now 60 into 1000 divided by 3600. If you simplify this, you'll get the value 50 by 3 meter per second. So that's the final velocity of the bus. Now students, we have to calculate the acceleration of the bus. You know the formula to calculate the acceleration of the bus. We have acceleration is equal to v minus u by t. So substituting all the appropriate values in their appropriate places, like v, the value of a v is 50 by 3. This minus is written here. And u, initial velocity, is 20 by 9, 200 by 9. And divided by 5. The time taken is 5 seconds. Now this is a bit of a simplification. So taking LCM and simplifying, we will get the value like this. So this is our final value, minus 10 by 9. You simplify this, you'll get the value minus 1.1 meter per second square. Now student, pay attention. You've got the value of minus. Acceleration is negative. What does this indicate? Negative acceleration means it's a velocity or the speed has decreased. In this situation, you see the bus has decreased the speed from 80 km per hour to 60 km per hour in 5 seconds. So the speed has decreased. Now that is indicated by the negative sign of this acceleration, student. That's all. Now student, let's see another problem from our NCERT textbook. It's a question number 8.7. It's a solved example. Example number 8.7, page number 109. The brakes applied to a car produce an acceleration of 6 meter per second square in the opposite direction to the motion. If the car takes 2 seconds to stop after the application of a brakes, calculate the distance it traveled during this time. Student, you read this question carefully and try and list all the important quantities that is given, and also write the quantities that we need to calculate. Now students, see, the brakes applied to a car produce an acceleration of 6 meter per second square. That means acceleration is given to us. So acceleration I have listed here. Acceleration is equal to minus. Now why minus? Because if you read this question carefully, you will see the brakes applied to a car. So when we apply the brakes, what happens to the speed of a car? The speed of the car will decrease, of course. So the acceleration will be negative because the speed will decrease in the opposite direction to the motion. The car takes 2 seconds to stop. So time taken by the car is 2 seconds. Now this time is taken by the car to stop. Of course, if you apply the brake, the car will not come to rest at once. It will take some time. So the time taken by the car to come to rest is 2 seconds. So after some time, the speed of the car becomes 0. So application of the brakes. After the application of the brakes, calculate the distance it traveled during this time. So we applied the brake. The speed slow downs. So during this duration, the car travels a certain distance and comes to halt. So in this 2 second duration, how much is the distance covered by the car? So that distance we have to calculate. Now student, when we say acceleration, it means it's a uniform acceleration. Now student, uniform acceleration, we have 3 equations of motion. U is equal to V is equal to U plus AT, S is equal to UT plus half AT square, and V square minus U square is equal to twice AS. These are the 3 equations of motions that we can apply in this acceleration involving problem. So whichever questions we get in our syllabus, it's about the uniform accelerations. So these 3 equations of motion can be applied. Now student, they are asking us to calculate the distance. Now in these equations, we can see here we have a distance, here we have a distance. In these equations, we don't have any distance factor. So now if I want to use these equations, just think, can we use these equations to calculate the distance in this question? Now to calculate the distance, using these equations, we need initial velocity U. Initial velocity is needed. So is initial velocity given to us? No initial velocity is given to us. Acceleration, of course, we have. Time, of course, we have. But we need acceleration. So acceleration not given. So this formula is ruled out. Now let's talk about this equation. Is this equation applicable in this question to calculate the distance? To calculate the distance, we need acceleration. Acceleration is given. We need final velocity. Final velocity is known to us. Initial velocity is not given. That means, student, we cannot use this 2 equation unless we know the value of a U. U is not given to us. That means the first task is to calculate the initial velocity. Now to calculate the initial velocity, we will be using these equations. Now student, let's use this to calculate the initial velocity. V is equal to U plus AT. V, final velocity is 0. We have to determine the U. Acceleration is minus 6. Time taken is 2. So 0 is equal to U minus 12. If you simplify this, you will get minus 12 equals minus U. So U is equal to 12 meter per second. Now that's the initial velocity of the car. That means the car was moving with this initial velocity. We applied the brake. The speed of the car slowed down. And after 2 seconds, the car came to rest. Now student, we have all the required quantities. Initial velocity is known to us. Final velocity is also known to us. Time is there. It's a 2 second and acceleration is minus 6. Now we have V is equal to U plus AT. S is equal to UT plus half AT square. And V square minus U square is equal to twice AS. Now I think student, to calculate the distance, we need initial velocity. Time is T. Acceleration is A. So we can use this equation, this given quantities, to calculate the distance. We can also use this equation to calculate. That means any one of these 2 equations now can use to calculate the distance. So let's use this, student. The third equations. Let's use this third equation. V square minus U square is equal to twice AS. V is 0. 0 square. U is 12. 2 into acceleration is minus 6. And S is the distance. So it's a 0 minus 144 is equal to minus 12 into second. So minus 144 is equal to minus 12 into second. So S, not second, it's a distance. Minus 144 divided by minus 12. If you cancel this, you'll get 12 meter. So this is the distance covered by the car. Now student, we can also use this equation to calculate the distance. Let's find out. S is equal to UT plus half AT square. U is 12. Time is 2 plus half into acceleration is minus 6 and time is 2 square. So 24 plus 2 minus 6 into 4. So it's 24 plus 2 into minus 24. So 24 plus half minus 24. 24, if you cancel this, you'll get minus 12. So 24 minus 12 gives you 12 meter. So you can use any of these two equations to calculate the distance if the given data is available. So that's how we got the value. Using both the formula, we've got the answer. That's all. So I hope students with this three problem, the problem solving skills, I hope you got it. So if you practice the questions, you'll be able to solve number of such other questions. Okay, thank you.